Welcome to Chemistry Simplified. In today's presentation, we're going to learn how to draw Lewis structures. And this is part one. First, let's look at some of the rules that we're going to be using to properly draw Lewis structures. Rule number one, we need to find the total number of electrons we have available. Number two, we will draw the structures by giving 8 electrons to each atom. Right? Because they need 8 electrons in order to fulfill the octet rule. Because atoms react forming covalent bonds in order to achieve the octet rules. Remember the nonmetals? These are the ones that form covalent bonds in order to achieve the octet rule. Number 3, we'll count the total number of electrons around every atom to ensure that they have 8 electrons. And if we added more than electrons than necessary, we need to remove the excess electrons from the central atom, from the one in the middle. Number 5, if you did not add enough electrons, you would need to add the extra electrons that would be needed around the central atom as well. Just like you remove from the central atom, you would add to the central atom if needed. Number 6, if the central atom did not fulfill the octet rule by having 8 electrons, we'll use lone pairs around the other atoms to form double bonds with the central atom. So these are the rules that we're going to be using to draw the Lewis structures. Let's look at our first example. Draw the Lewis structure for carbon dioxide. First, we need to find the total number of electrons we have available, which would be given by the group number times the number of atoms. For example, we need to find the total number provided by carbon. Carbon is in group 4. From the periodic table, we can see that, and we only have one carbon, so 4 times 1 equals to 4. So carbon provides 4 electrons. Oxygen is in group 6A. It provides 6 electrons, and we have 2 oxygen. So 6 times 2 equals to 12. So oxygen provides a total of 12 electrons since we have 2 oxygen. And if we add the numbers, we have a total of 16 electrons. So we cannot have more than 16 electrons. Next, we'll place the least electronegative atom in the middle. So let's bring the table that tells us the value for electronegativity of each atom. So we're dealing with carbon dioxide. So oxygen has an electronegativity value of 3.5, whereas carbon has a value of 2.5. So carbon is less electronegative than oxygen, so carbon will be in the center, will be in the middle. Place carbon in the middle, and we have 2 oxygen. Next, we draw a single bond between the atom in the middle and the other atom. So single bond between carbon and each oxygen. We know that each bond represents 2 electrons. So this is 2 electrons between this carbon and the oxygen, and another 2 electrons. So we can see that carbon has 4 electrons so far because it has 2 bonds. Each bonds represent 2 electrons, but each oxygen only has 2 electrons. Then we need to place lone pair electrons on each atom to make sure that they fulfill the octet rule, meaning that they all need to have 8 electrons. So we place 6 more electrons around this oxygen because it already had 2 from the double bond. We'll do the same thing for the other oxygen. And carbon already had 4 electrons, so it needs 4 more. So everybody fulfills the acted rule, but we need to make sure that we did not put more electrons than necessary. So when we count the total number of electrons, we found we added 20 electrons, but we need only 16. So we had to remove 4 electrons from the central atom, from carbon. So we're going to remove 4 electrons from carbon to make sure that we have 16. So we remove these 2 electrons, we cross them out, and we remove these 2 electrons. Right? Now we have a total of 16 electrons, but carbon is not happy. Carbon needs to fulfill the octet rule. Remember, atoms shares their electrons in order to fulfill the octet rule. So carbon doesn't have 8 electrons, so we need to make sure that it has that 8 electron. So therefore, we'll take one lone pair from oxygen, from any of these oxygen, to form double bonds with the carbon. So we take this pair of electrons from this oxygen and we create a double bond. Carbon is still not happy, right? Carbon only has 6 electrons. So we're going to repeat the process again. We're going to take 2 electrons from the other oxygen in order to form another double bond. And this is the structure for carbon dioxide. Every atom fulfills the octet rule. Everybody's happy. So this is what carbon dioxide should look like. Example number 2. Draw the Lewis structure for nitrous oxide, N2O. We need to find the total number of electrons we have available. Oxygen is in group 6. We only have one oxygen, so 6 times 1 for 6 electrons. Nitrogen is in group 5A, so it's 5 times 2 because we have 2 nitrogen to give us a total of 10 electrons for nitrogen. And when we add them together, the electrons provided by oxygen plus electrons provided by nitrogen, we have a total of 16 electrons. We need to place the least electronegative atom in the middle. So let's look to see which one is less electronegative. Oxygen has an electronegativity value of 3.5, whereas nitrogen has an electronegativity value of 3. So nitrogen should be in the middle because it's the least electronegative. We draw single bonds. We place lone pairs of electrons around each atom to make sure they fulfill the octet rule. So this oxygen needs 6 more electrons, which we just placed there. Same thing for this nitrogen. But the nitrogen in the middle already have 4 electrons, right? Because it has 2 bonds. Each bond accounts for 2 electrons. So it needs 4 more electrons. Right? So everybody fulfills the octet rule so far. But we added 20 electrons, but we needed only 16. So we got to remove some of the electrons. Just like we did previously, we need to remove 4 electrons from the central atom, from the nitrogen in the middle. Let's remove those electrons. Now we have 16 electrons. However, the nitrogen in the middle is not happy because it did not fulfill the octet rule. So we're going to take lone pair electrons from the other nitrogen to form double bonds with the nitrogen in the middle. We take 2 electrons from this double bond, and we take 2 more electrons from the nitrogen again to form a triple bond. There it is. Now, some of you may wonder why I didn't take electrons from oxygen to form a double bond instead of taking another pair of electrons from the nitrogen. In future presentation, we'll talk about resonance structure. That shows that the structure that we have here is the most stable one. It's possible to do the other one, but it would not be the best answer. So we'll explain that in further lectures. So every atom fulfills the octet rule, so everybody's happy. So this is the structure for nitrous oxide. This is the end of our presentation. Please remember to like, subscribe, and share, and use the comment section to let us know if you had found the presentation to be useful. Thank you and have a great day.